Okay, welcome back to this video. In this video, we will see about the Stack ADT, how LIFO principle is used in Stack. Okay, now let's see about what is Stack. A stack is a linear data structure that follows last in, first out. Usually we call it as LIFO, which is nothing but last in, first out. Okay, imagine a stack of plate. Let us consider a stack of plate. Okay, this is a stack and contains plate 1, plate 2, plate 3, plate 4, plate 5. Okay, in this stack we used to add a plate at top, and if we want to remove a plate from it, we will remove the plate which is at the top of the stack. This is the concept of stack which works in the principle of LIFO. Okay, here we have basically three operations, key operation which is push, which is pushing into the adding an element, and pop is removing the top element, and peek which is nothing but viewing the top element, and which is common in undo functions and function call management. Okay, here let's consider an example. Think of opening a Word document in a computer, and if you are typing few words. Okay, each action you do, it may be typing or deleting or format, that operation is called as push, which is pushed into the stack. And when you press undo, if we are pressing undo, the last action performed is popped out. That is called the LIFO concept. Okay, now let's see about the push operation. Okay, for pushing an operation, we have to identify a concept or identify a thing, whether this stack has anything inside, or if the stack is full, or if the stack is empty. Okay, first we identify the current top of the element. See, top is nothing but the word which we represent the pointer where it is located in the stack. If the stack is empty, we usually say that top is equal to -1. If the top is equal to -1, we can identify, our system can identify that the stack does not contain any element in it. Okay, if there is no element inside the stack, automatically we can add our element into the stack by adding the top become +1. So -1 + 1 will become 0. The element which is, suppose consider an element 5 which you are going to pop inside the stack. This 5 will come in the inside the stack in the position index of 0. Okay, since the top stack does not contain any element into it, the top was initially -1. Currently we added an element into the stack, and the element is stored in the position 0, and the top position is in 0. Okay, similarly we can add more elements by incrementing the top. If we add 6 will come here and top will move to 1. If we add 7 will be here and top will be in the position 2. Okay, this is how push operation is performed. Finally, we insert new element at the top if the stack is full. Okay, if the stack is full, this operation cannot be performed, then the result will be overflow. Okay, if the stack is full, we cannot add any further element into the stack, the output will be overflow. Okay, this is the concept of push. Okay, let's consider an example which is already taken. Okay, if you consider a theater which is a capacity of 100 seats per screen. A ticket can be produced only to the 100 members, and if 101 member is coming and asking for a ticket, we cannot give ticket and we cannot accommodate into the theater because the capacity of theater is only 100. So what we will be saying is ticket full. Okay, that is the concept here. What we will be saying in the technical term is overflow. Okay, next we will see about the concept of pop operation. Okay, pop is nothing but removing an element from the top of the stack. First check if the stack is empty. Here also we have to check whether the stack is empty. Empty is nothing but the top position will be -1. If the top is -1, obviously we can identify that there is no element inside the stack and we cannot perform pop operation. Automatically the system will return us as underflow. Okay. While inserting, if the stack is full, the error which we receive is overflow, and while popping, that is deleting, if the stack is empty, we will receive an error as underflow. Okay. If it is not empty, obviously what we will be doing? The top element will be popped one by one and the pointer which is top will be decreased by one position at each popping operation. Okay, hope you understand this concept. Next is peak. Peak is nothing but at the top of the, just viewing at the top of the card of deck, you just look and do not remove. We are not going to perform any remove operation or adding operation or pushing operation or popping operation. Just we will be seeing. We will check whether that stack is empty, or maybe we can return the value which what is the element is placed in the top. Okay, the structure of stack remains unchanged. While performing peak operation, the structure of the element will not be changed. The structure will remain unchanged. Just we will see whether an element is present inside the stack, or what is the first element, top element inside the stack. For that purpose we will be using the peak operation. Okay. Okay, already we have seen that we will be having two error operation, which is nothing but stack overflow and stack underflow. Okay, overflow is trying to push onto a full stack. If we want to push an element into a stack which is already full, we will receive an error as overflow. And if we want to delete an element where we element from the stack where the stack is empty, it is called there we will receive an error as underflow. Okay, this should be checked before doing any operation. Okay, next we will see about the application of stack. Stack have several practical applications. Evaluation, expression evaluation, which we have already seen in previous video, which is infix to postfix conversion. You can refer to that video. And function called stack that tracks the nested function calls. Undo or redo functionality. Apps like Photoshop uses stack to backtrack or redo the action. And browser history is also works according to the stack operation, allows you to go back and forward through visited pages. And for example, you can take as in calculator the expression which we will be giving, right? If you give 2 plus 3 star 4. Okay, here we will be performing the infix to postfix conversion, and then the evaluation is done. Okay. Okay, I hope you have understood the concept of stack. Here I will summarize what we have seen so far. Stack works on the principle of LIFO, which is already we have seen, and key operations like push, pop and peak function, and they are widely used in real life applications like programming, browser and editor. Understanding the stack lays the foundation for more complex data structure algorithm. Okay, this will be the more important concept in data structure. Hope you understood the video. We will see you in next video. Bye.